Greetings to respected Madam Sir. I'm Pavan Sai of second year CSE AIML student of section C. So this presentation focuses on computer systems architectures, specifically implementations, processing, interpretations in pipeline, RSCI processors. So computer system architectures implements precision interpretants and pipeline RIS processor where in implementations stands for how hardware and software components work together to execute instructions efficiently. So the processing, the flow of instructions and data through the CPU and memory. Interpretation in pipeline, how the system handles data, how the system handles delays, hazards or exceptions during instructions executions. RSC processors, a processor designed that simplifies instructions and to improve performance efficiently. So this presentation explores the implementation of precise interpretation interruptions in pipelined RISC processors. We will be examine the significance of interruptions in RICS, the RICS architecture, the various types of interruptions and unique challenges posed by pipeline. Through this, we illustrate techniques to ensure interruptions handling, enhancing processing efficiency and performance in modern computer systems. So precision in interruption handling, precision interrupt and which are crucial for maintaining the integrity and functionality of RISC processors. They enable the system to respond to events while ensuring the execution states, which can be seamlessly restored. This allows for accurate context switching, vital for multitasking and time sensitivity. Applications understanding their roles helps in creating more reliable and efficient processor designs. So precision in interrupt handling ensures the state of processor appears as if the instructions are executed in order. Even occurs, uh, when an interrupt occurs, the systems should be able to resume execution correctly without losing data or executing the instructions incorrectly. Requirements for precision interrupts. All instructions before the interrupt are fully executed. No instructions after the interrupt are executed. The processor system can be saved and restored accurately. So the importances are preventing data and corruptions and ensuring reliable program execution, and critical for pipeline in modern CPUs where multiple instructions are processed stimulatively. So types of interruptions. There are several types of interruptions, including hardware interruptions, software interruption, and time interruptions. Hardware interruptions are generated by external devices, where software interruptions are triggered by programs. Time sensitivity helps in managing multitasking by allowing the processor to switch between tasks and intervally. Each type presents unique challenges for precision handling in system architecture. The role of pipeline in handling interruptions. Pipelining significantly improves the throughput of RISC processors. However, it introduces complexity in handling interruptions. When an interrupt occurs, the processor must pause its current operation and address the interrupt while ensuring the pipeline instructions. Maintaining consistency, this pipelines ensure that all instructions will be complete correctly while minimizing the performance penalties. So implementation techniques. So precision interrupt to design precision interrupt, it is essential to implement specific hardware and software mechanisms that precisionly track the execution state and instruction techniques, including using additional registers to store states information and revising instructions set to facilitate interruptions such as help retain context and enable successive handling of multiple stimulations interruptions. And the goal is to ensure that when an interrupt occurs, the processor state is consistent and it can restore correctly. And the key designing strategies are pipeline flushing, removing partially executing instructions from pipeline to prevent incorrect executions, and the instruction completion tracking keeps track of which instructions have fully completed and which are in progress. State and saving saves all the registers, program counters, and relevant flags so the processor can resume correctly after the interrupt. So recorder buffers, also we can say reservation section. It is an in advanced CPUs. It allows instructions to execute out of orders but commit results in order to maintain precision. So the benefits are guaranteed data integration and system reliability, enabling the smooth interrupt handling in pipeline and modern superscalar processor. Example, in a five-stage pipeline, if an interrupt occurs at a stage 3, the processor can flush stage 3 as well as 5, saving the state. So handling the interruptions and resuming executions from stage 3 without affecting instructions of 1 and 2. So managing pipeline stages with interruptions. Managing pipeline stages during interruptions involve maintaining clear definitions of instructions stage to prevent errors. Techniques which are included: stalling pipelines, flushing specific stages, or using advanced states tracking technologies. Each method has its advantage and trade-offs in terms of performance, impact, and complexity, necessitating careful considerations during system designs. In the case study and the applications, various applications illustrate the implementations of precision interruptions in pipeline RISC architectures. Real-world case studies highlights performance improvements, showcases how precision interrupt handling can enhance multitasking, real-time processing, and system reliability. These examples provide valuable insights into better practices, the practical challenges faced in modern computer environments. Conclusion: the implementations of precise interruptions in pipeline RISC processors, it is essential for ensuring reliable system operations. By understanding the importance of interrupt types effectively, managing pipeline stages, and applying design strategies, we can enhance processor performance and efficiency. Ongoing research in these areas will further refine methods and the solutions for challenging scenarios, paving the way for acknowledgement in computer technologies. Thank you.